Okay. So what we did on Monday was this very simple class called GPS DD. It's a object-oriented representation about GPS location and its possible interface to this object. So what is a GPS? A GPS really just two floating point, but in the implementation, we use double, which double in C or C++ represent a double precision floating point, means that it's actually providing more accurate internal information about our location. And so this is I use this as a good practical first example for how do you actually define a class. How do you define a class? There is two parts. One is syntactically how to represent what are the keywords, what are the syntax for you to specify what's the data or private part and what's the interface part, which is the public part. So think about object-oriented paradigm. You always have the private part and the public part, and for good reason. The private part is actually trying to keep to ourselves and don't let other people to randomly access the data. For example, in this case, the longitude and latitude is actually a private part because we don't want other people to just randomly come in to modify the position. And we actually want whoever use this object to actually follow the interface. And that's why we define in the public part. By the way, I have to say that this is just an example about the public part I defined here. I mean, for example, you say, well, this interface is kind of not so good because it doesn't allow me to change the GPS location. You look at the interface, the only time you can change the location is when you create the object. When you create the object, one is called constructor, this line. If you see the class name being used as the function name, member function name, and that means it's a constructor. And there are multiple types of constructor, which we will go into in detail. If you read your chapter 11, it actually talk about 3 types of constructor. Default constructor is one of them. There is a copy constructor. There is a move constructor. There are 3 types of constructor that serve different purposes. But in this example, regardless of what is a constructor, the constructor was the only place that you can change the location, which might or might not be correct, depending on how you use it. So whatever I define here, you can see that is defining has a syntactic part, but also has how you're going to use it. Because once you define that this, we're not defining object just for good looking. We're not defining object just for represent the information. We want to define the interface such that it can be used, it can link to other objects in the system, and such that together they will actually be able to solve something really significant. Okay, so that's what we kind of more or less cover. So let me repeat again. Syntactically, you have a keyword class and the class name, which in this case is GPS underscore DD. And then I have a 2 internal variable, which is a private part, is latitude and longitude. And then I have 6 member function as the interface for you to access this object. So that's how I declare the class, which means that all the objects instantiated under this class will share exactly the same structure about the object. Okay, all right, so any question? Yes. Okay, The first GPSDD, in fact, is what we call the default constructor. So the default constructor, it doesn't take any parameter. It just default. Let me actually show you. That's a good question. Sometimes the default constructor might not be terribly needed, but let me actually show you. Look at the implementation. The first one, the first 4 line, that's actually the one without parameter, right? And then the second one is actually have a 2 argument, which is I use both double. The first one, the variable name is called arc latitude, arc longitude. Okay, take a look at this code. This is just a very simple example. The first code, because I didn't specify any argument, so I just set it to be 0. So you can see that this is not necessarily useful. Most cases, we're actually using the second definition, which is the GPSDD with 2 latitude and longitude, and I assign the value to the latitude and longitude. And remember that I use the pointer notation. This is actually an address or pointer to the first byte of this object. Okay, if you're familiar with C pointer, okay, this is not the like a Java pointer. C pointer, a pointer is a memory address. So that address representing the first byte of the object. Okay, I just want to give you a heads up. Let me ask the question. I just, some of you probably never heard about this concept. For those of you who've taken the C programming course before, have you heard about something called casting or type casting? You heard about type casting. Okay, if you typecast a pointer, you do a type, for example, this is integer star, which is the pointer to an integer. If I cast to a character star or cast to a double star or struct some star, when I do a casting, does that change the value of the pointer? This is a very tricky question. Does casting change the value, the address of the pointer before and after you're doing casting? This might be tricky because if you only take ecs36b within the context of C programming, casting never change address. Regardless how you change the type of the address, the address should still be the same. Okay, that's actually a bit confusing why I'm asking this question in C++ then. In C++, later you will learn a concept called inheritance. And to make it more complicated, that C++ has 2 inheritance. One is called virtual inheritance, one is called multiple inheritance. When you have inheritance, when you do casting, it actually changes the pointer value, change the address. And we'll explain that later. Okay, so therefore, this usually is the address of the object of that particular type. Because why I'm divert myself into this, because in C++, that this is a reference to an object, but in C++, because of the inheritance, that sometimes this object might be contained or actually being concatenate within each another, one another to represent a more complicated object. For example, I have a class called person, and I have a class called student. And student is also a person, so you can imagine that the student object has one part, which is actually the class person, and therefore you essentially have a multiple this in that case. So what I'm saying is, when I say this must be correspond to the scope of GPSDD. Okay, that's remember that this is a number one I want to tell you. The second thing I want to tell you is that these two are equivalent. Okay. These two are actually going to be equivalent this way or this way, with or without this. These two are actually equivalent. So when you, within the scope of GPS-DD, when you say latitude, is actually represent this to the latitude. And so now I want to show you the code. If I actually show you this code or this code, this is option 1. And this is option 2. They are syntactically the same. Okay, they're syntactically the same. The compiler is going to compile into exactly the same code. So which way do you think is better? To do an option 1 or option 2? I told you that I'm just adding something called this, but why not just without this? I can still accomplish the same purpose. Yeah.
Might be a conflict if a parameter name has the same name as the data member name.
Exactly. That is one of the main reasons, because you might have a conflict, right? Having say this is unambiguous. Refer to that. Okay. The other reason, yes, please, in the back.
So this is like, it doesn't, I'm confused on how it's used.
Yes. In a short answer, you're right. It's not doing anything. It's not doing anything after the compiler. The compiler is going to transform those two lines of code to exactly the same. So this, in this case, is more for readability, and also try to avoid some kind of ambiguous. Because just what's your name again? Nicholas. Nicholas. What Nicholas mentioned is that what happens if you have a larger piece of code and you actually declare a variable, and so this will help you to actually refer to the code that particular variable. Maybe they have the same name, is actually under the class GPS. So that is one reason, but the other reason is readability. So you see that when I give you the sample code, I always follow option 2, which is just having this. So we won't have second thoughts about checking whether this variable is already defined within that, because that, I mean, just tell you that I could have this one. I could define something called float. For example, I might define this one. I might define this and then say this is equal to 0.3. Okay, I can actually say this. So then this make option 1 and option 2 going to be semantically different, because option 1 is actually going to refer the latitude to this 0.3, this variable, while option 2 is actually always referred to the one that's actually in the class definition itself. Okay, so that is a big difference. So sometimes it's just make things less ambiguous. Yeah.
So, they're gonna change the private.
With option 1 is not changing the status about the private, because this is a member function. So member function already has the authority to access the private member. So how do I know it's a member function? Any function that's defined with the class name with colon, 2 colon, that means this is the member function of GPS-DD. So if you actually, so compiler is going to check, by the way, just follow up your question. Whenever you do this, for example, I actually make a spelling. I actually make instead of lowercase, say get latitude, I actually make it to be the capital T. Okay, I make a mistake here. let's see what happened. So let's see what happened if I do Control X, Control C, and I do a make. You see that? It's actually going to say, they said, well, they actually guessed, I might say, yeah, latitude, but basically the definition does not match any of the declaration in the GPS DD. So let me change something which he cannot guess. Gosh, this day the compiler is getting as smart as ChatGPT, I guess. Get something ChatGPT. Okay, I just changed this to be something totally he cannot guess what it is. I do type a make. It basically now this time is just outline. He said, well, you actually define a member function because I use a GPS DD colon notation. It realized that the definition of this does not match any of the declaration of GPS DD, which is included in the GPS.h. Because in GPS, it doesn't have that, okay? So this compiler is going to do this kind of check. You declare the interface, whether you really implement something that match that interface, okay. I better change it back. Okay. Okay, this hopefully get you some idea about the first class you ever see. Both the how do you declare, how do you actually be able to create the function. So now I'm going to move to the next step. I want to use it. Whenever we define a class or try to create some object, I'm not just let it sit there. I want to see how it can be used. So I'm going to actually show you how it can be used, okay? So I'm going to look at my test function in the same directory. Let's look at test mistake. Okay, this is the driver program or test program. You can see that this is your typical C program with a main function. I'm going to just show you something very quick here. So, okay, so the first line over here, I'm actually creating a, so you can see, okay, number one, I didn't include GPS.h, but I want to tell you that in the person.h, yeah. In the person.h, I include GPS.h. So essentially by including person.h, I indirectly also include the GPS. So you already should know about GPS at this point. Okay, so the first line over here is actually creating an object. So you can see that I give the class name. You can think about this as like a data type in. Instead, is a class type. Okay, it's a data type, but this is a class. And then the name of the variable, I call it GPS home Woodland. Let me just, anybody want to guess what this location is in Woodland?
Like a street?
Not street, a particular store. Actually, I just pick it up. No, it's Costco. Okay, I almost live there. So I use the example on Woodland because I use that a lot. Okay. All right, it's actually Costco. I should have changed it to Costco, but for some reason I feel I live there. Okay. If you enter that GPS location, it is. So okay, so you can guess that this part is really try to fit into the parameter of the what? Of the constructor. By the way, I also have two different ways to do this. I can actually do this, or I can do this. If you look at the second way, this might be more familiar with like a function call kind of thing. Okay, you can do like the second way or the first way. But C++, since I forgot which version, has already support the first way, which now the first way became the more commonly used. This is what we call bracket initialization. bracket initialization means that when you define a object, variable name object, in this case, GPS home Woodland, and you essentially just put in the initialization variable, initialization, whatever, the value over there, that will help you to decide which constructor you're going to call. So in this case, let's actually go back to the GPS.h. Because I have two constructor, I have a two constructor double. So this two is going to match that particular constructor taking two. That's how it's actually get initialize the value. Okay, so let me actually tell you that this is important. What happened if I actually give three of them instead of two, right? I give three of them. Let's try to make it. You see that? It's basically say, hey, wait a minute. I try to match it that the you see that the candidate constructor is not viable because they require two arguments, but you actually provide three arguments. And they're basically trying to match the type and match the number of argument as well. Okay. One second, let me actually change it back before I answer your question. So I'm actually going to change this part, get rid of this. Okay, now I'm happy. Yes. Well, this is actually a very unique syntax for you to call the constructor. So you can think about when you declare a variable and then you actually just put a pair of curly bracket, and that's actually not a function body or whatever. Whatever inside that pair of curly bracket is the variable that you're going to connect you to the constructor. Well, by the way, when I first wrote C++ program in the 80s and 90s, we didn't have this. So this is a new one, right? Probably around 2010 or 2011. Yeah, maybe it started on C++ 11. Okay, so that's the first function. So you can see that, okay, I'm actually already called this constructor. Now you see that I connected that. Now I'm actually going through the rest of the program. By the way, any question? Okay, so you can see I actually create two GPS location. One is called Home Woodland, one is called TLC UC Davis, because in the fall 2022, our classroom is in actually TLC. And then I basically create a person. I haven't told you what person object is, so now I want you to guess what the interface looks like. So I actually create another class called person, and I name this object Felix. And this object actually has three arguments, is a constructor. The first one is maybe a social security number or student ID number, whatever. You know that number is a fake, right? You don't believe that's my social security number. And the second one is also a string, is my name. And then there's my location. So essentially when I create, so I'm actually may have some hay fever or something. Let me. 1 second. Okay. So in the person, you can imagine it has a constructor which take three arguments and correspond to this three pieces of information. And I just move forward very quickly. And then I actually create another object, another GPS location is actually IKEA in Sacramento. And then this is interesting, I actually create a thing. And I call that thing Swedish nibble. Okay, don't ask me why I picked this example. It actually reflects my preference in real life. Okay, and I create this called Swedish nibble, but the constructor I provide has only one object, and that object is what? It's a person. So previously we say in the GPS object, the constructor take a two double as the argument. And when I create a person, it actually takes a two string and a GPS object because I want to know where that person is. And then basically I create another thing called Swedish meatball, that this meatball was purchased by the person, which is Felix. So Felix basically got that meatball over here. Okay, so that I create the object called Swedish meatball. And then after here, you can see that I actually changed some of the parameter about that Swedish meatball, about model, sequence number, description, and the location of that meatball. And the location of the meatball is actually at home right now. It's no longer in Sacramento. By the way, it was in Sacramento, but I took it home. That's why it's actually at home. Okay, so that's, yeah. Which line? Okay, good question. Let's actually take a look. So what class is a Swedish meatball? Thing, right? Okay, so let's look for thing.h. Remember, we always go to the .h file to look at the interface. So now we look at the thing, you can see that why now you have everything you can access because I put everything in public. There's nothing private, nothing protected. Don't worry about what is protected. Protected is related to inheritance. Okay, not worry about that at this moment. But I put everything in public. And therefore, because everything is in public, that variable itself is actually an interface itself. It allows the user of this meatball be able to directly modify everything they want. Okay? Does that make sense? You can see, look at the thing. Thing has a model, has a sequence number, has a description, has an owner. And then it has two timestamp, which is called JB time, which is, that's the, by the way, this set of code, I have 4 different classes. I have the GPS class, I have the person class, I have the thing class, and then I have a time. Excuse me. Yeah, it's a hay fever time. I'm getting there. So I have a 4 different class, and that's what I have there. I better wear my mouse mask and talk. Okay. All right. So let's take a look at the rest of this. That's why all this are the variable, and then you can take a look at the constructor of thing. The constructor thing also have the first constructor without taking anything. Okay, now you see I use the word void. You don't have to put anything. If you don't put anything, that's nothing there. And then the other constructor is actually taking a person object, which that's why I actually have a thing, curly bracket Felix over there. And then I also have the dump, which is basically try to print out all the information. If you want to know the detail, go to thing.cpp, and then you can see that, oh, wait a minute. Don't worry about the first one. The first one is called my print log, and that is the function I actually tried to deal with the log. But this is basically the constructor thing. The second one is the thing, and then the dump. Dump is essentially just print out whatever information you have over there. Okay. Any question? So now let's go back to the program, the test program, because this actually help you to understand the scope. Okay, so essentially what we did is that I create a bunch of GPS objects. I create the person called Felix, and I create another thing called Swedish meatball. And then I basically start to describe whatever it is. And now I actually try to do the next line is set location. So essentially this line is basically say, okay, good. I'm actually in somewhere because every person should have a location according to this. Let's actually take a look at person.h. So you can actually see side by side. So this is a person class. And I have the private. You can see that the private has one of the, I have a home where I live as a location GPS. I also have a current location, meaning that I'm actually move around. And that location has also a time about when I was there, for example. So that's the person. And then within the public interface, I have one function called set location, basically saying that when was Felix at this particular location. So I'm actually trying to do some kind of Google map kind of tracking, set location. So over here, you see that I'm actually calling that function. I said Felix dot set location GPS TLC Davis get now JV time. So get now JV time is actually for me to get the current timestamp when I run this program. And the GPS TLC UC Davis was actually the classroom. So if we're in actually TLC, then essentially I'm setting right now. I'm actually TLC. Okay, so I'm actually using a function call with involve 4 different objects, 4 different classes. I can actually start representing something quite interesting about where you are with what kind of thing you are. Because the thing, for example, you can say switch meatball is a thing, or maybe this coffee mug is a thing, or your phone is your thing. And then you can actually start to represent the concept about the person and the thing. You can actually start to take care of a lot of issues. But the most important thing I want to tell you right now is that this might be actually a kind of toy example. What I want to tell you is, number one, how to define a class, and how to define the interface, how to implement the interface. And the second thing I want to tell you is that, well, how do you actually be able to use this interface to create some form of the scenario of the application scenario you would like to implement, you would like to represent. And with this, then you can actually develop a different type of application, okay? Any questions so far about the first set? Yes, please. Okay. It's exactly the same as C, that you have both called by value and called by reference. So typically over here, if I actually do GPS DD, if I do this is called by value. Means that when you call it, you actually copy a value into that. But you can actually do this, then this become called by reference. If you do this, sorry, if you add M, this is also probably the new syntax for C programmer. If you say GPS DD M, that means it's actually called by reference, meaning that you pass the object into a member function. Inside the member function, if they change the value, it will be observable from outside. So it didn't make a copy, it's the same copy. Okay, you have a question here? Yes. Say it again. What? Oh, the set location. I didn't have any. So here's a set location, right?
Person.age.
Oh, this one? Oh. Oh, I see. Okay, sorry. Where's that? Oh, this, okay. Sorry. Okay. Okay, what is a star? Okay, so it just returned the type and I dereferenced that. So let me actually go to, I think it's in JV time.cpp. You see that this is the function get now JV time, right? And the JV time is actually returning a pointer to the JV time object. Okay, that was a design for some reason. And I put a star, meaning that I actually dereference the pointer, and now this whole thing become the type JV time instead of JV time star. So I basically try to remove that star return by get now JV time. Okay, thank you. I want to go back to the reference question. I just realized something which is okay. So I said you can do a reference by adding an M. In fact, I have an example here. This line. It is an interface, but its interface is somewhat different. It's a name called operator and with two equal sign. Operator, two equal sign. And then inside here, I take one parameter, and this parameter actually is a person N, which is the reference. I'm actually using one parameter. This particular example, I'm not going to answer today because it involves a whole lecture to talk about what do we mean by operator equal equal. By the way, I want to ask, have anybody actually seen this kind of notation? Operator equal equal. Okay, okay. You have seen it? What's the meaning of operator equal equal based on your understanding? Right. Okay. Some of you know that, right? So this is what we call operator overloading. The technical term is called operator overloading, which is a whole new lecture I need to provide, but I'm not going to directly get into that because I have a few things I need to build up. Okay. But in the operator overloading, we use the reference, the pass as a reference a lot. Okay. So just start to be touching those terms. Okay. Operator equal equal. So this small example does have a few things I intentionally put in. There was a question over here.
Well, I was just gonna answer.
Okay. Okay. Good. All right. All right, so this is the first four set of example. That was person, thing, JV time, and the GPS. I'm not going to go into the JV time, but you can actually download the code, play around, and take a look, and ask me any question you want. Your next homework, which is homework assignment number 3, is essentially I'm actually providing you a scenario. And you're going to actually define your own class, your own interface, and your own test program to actually try to see how it might work to represent the target environment I asked you to do. So last year, I was actually asked the student to represent Little Red Riding Hood. You can think about Little Red Riding Hood has a bunch of person. Has the Little Red, has a big bad wolf, the grandma, mama, Little Red's mother, and then we have thing, right? Thing we have whatever whatever cake, wine, whatever he's carrying with him, and it has a location because he actually and the big bad wolf they actually meet at the entrance of the forest, and the big bad will follow that to grandma's place. So this 4-class thing, person, you can actually describe the whole thing. Instead of from IKEA to Costco, you can actually describe from whatever home to another home. Okay, so that's kind of things I want to show you. Okay, I want to use the last 10 minutes to show you something which is a little bit more about how to use the object to connect each other, but also motivate you why I asked you to do homework assignment 0. Okay. So by this time, I assume you kind of familiar with the Wordle C. How do you actually break it? How do you actually use it? And the code you're using is in C. I'm actually going to show you something which is actually represent C++, represent Wordle in C++. But this was actually, you can actually download it from my GitHub directory, dated November 23rd of 2022. By the way, this was a reference implementation for homework assignment number 6. But you have something which is familiar to you. You have JV time, and you can see that there's a lot of ecs36 project. But over here, what do we do here? So in the Wordle for your homework assignment number 2, essentially you have program, the program generate a game, and then you actually guess against that program. Okay, fine. But what I want to do here is I want to split, just like a real Wordle game is actually split between the client and the server. So the server part is the one who generates the game and push the game to the client, and the client provide a guess about what they need to be done. Okay, so I'm going to first show you the demo. You can take a look, and then we can see what we're doing. So this code is over here. Let me make it a little bit smaller. And by the way, we're going to do this a lot this quarter. So that's why I want you to start getting familiar with homework assignment number 0. Okay, I'm going to make it. Okay, so I have a client side and the server side. So over here, I have a server side, and over here, server side, if I look at the game, there's nothing. I have a subdirectory called game. This is the server side. Initially has nothing. So I'm going to run the server, HW6 server. Oh, by the way, before I do that, I just want to tell you, if you notice what happened, I do a make clean. If I do a make, you can see that the first line over here, what is JSON RPC stub? This is corresponding to your step number 1 for homework assignment 0. Okay, you're using this program. So that's why I want to make sure that you actually got JSON RPC stub installed correctly, so we can actually move on with such kind of very interesting program. Okay, I'm just using this, compile all the code using make. That's why make file is important. You don't have to type everything to compile everything. And then you see that I'm actually doing -L with my homebrew. That is always the curse of C++ programmer, that we have to deal with different environment. Okay, now I'm going to run the server. So by the way, when a few of you come to me saying that, well, how do I actually run step 3 or step 4? By the way, you need to create 2 different windows. Run the server first. By the way, the JSON RPC is essentially provide you a web server. It's give you the power web server. So that's why you need to run the server before you can test your client. You can see that I'm actually running the server. So the server is running over here. Now I'm going to run the client. Okay, so you can see that I'm actually start to provide some of the guesses. Okay, but the first thing you probably didn't see that is actually create a new game. So let me actually go to another one. You can see that my server part already see some guesses, okay, because I actually create a game. I'm actually trying to provide a guess, but I want to show you what the game looks like. This is actually the server side. So go to the game. You see, now I create a new game. I actually store the game in my file, in my server. Previously, it was an empty directory. Now I have this game. I call it Wordle. You can see that this is the game. The name of the correct word is Azure. That's a word it basically creates. And then so far, my client program make a 3 guesses, mount, Siki, and earth. And it actually recorded when you actually make the guess and what was the result. Okay, so Siki, yeah, nothing. And then earth is something like this. And then that's basically, we're doing exactly what you're doing at the single program version, but now we kind of split into the server part and the client part using JSON RPC. So now I want to actually go back to the client side to tell you what actually generated. Okay, so this is the program that's equivalent to the client side program you actually did with your homework assignment number 0. And it has a lot of part that's actually to do with HTTP, which is the server client protocol. That's why this one is essentially the client program. I don't know if you realize when you do homework assignment 0, you actually create a web browser. It's the client of a HTTP relationship, and you try to connect to a server, which is under the other program. So essentially what we did, let me actually just quickly, the first call, you see that I'm actually making a member function call. A member function call is a my client.obtain. And when I make this call, instead of calling that particular member function of the object my client, it's actually redirect that call to the server. So that is a member function call, but that member function call triggers another action, and such that I essentially can contact a member function that's actually from the other program, which is the server. So I'm actually interact with the object, but the object is actually not on the same machine. Okay, so that's the capability I want to mention to you very early in this course, because when we deal with object-oriented paradigm, we're thinking about, oh, we're writing a program to contact an object. But gradually you should realize the object need not be in the same location of your program that you try to run. In fact, when you look at object-oriented programming, a lot of case is actually you're trying to interact with object that's actually across the world. I mean, when you use any service like a Google or Facebook or Amazon or Google Maps, you're essentially interact with an object that's actually not on your computer, but it's actually on somewhere else, a server. So that's how you learn about programming, but on the other hand, you gradually see that what is the programming skill that you can actually distribute some real world application this way. Okay, so I'm going to stop here, and we're going to continue with the discussion today. Where's our TA? Oh, he must be already in the classroom over there. Okay, by the way, today's situation is a little bit different because I just realized